this problem? Well, what we got here, bolt through timber beam. Oh, wood. God. Don't know if I want to deal with that or not. What's there, anything different about that? What are we doing on that one? Determine the minimum required diameter. Oh, well, we do need to deal with this one. We do need to deal with this one only because now it's going to be looking at, we need to find out what the area is. Okay? So, which I guess we just did that on that last one, didn't we? No, not on the last one, but on that other wood piece. Yeah, we'll move on. Let's see, what's example 9.8? Now that one, no picture involved. So let's see, it says a 100-foot long steel bar is suspended vertically from its upper end. The cross-sectional area of the bar is 4 square inches, 2 by 2. The unit weight of the steel is 490 pounds per cubic foot. Compute the maximum tensile stress due to the bar's own weight and the maximum load, P, of the allowable load that can be safely supported at the lower end of the bar if the allowable tensile stress is 24,000 psi. Looks like a whole bunch of stuff, doesn't it? So it says first thing you do is calculate the weight per foot for this bar as follows. So what did it say? The unit weight of the steel bar is at 490 pounds per cubic foot. So somehow we have to get that down into pounds per feet. Well, look at there. So you got 2 inches by 2 inches by 12 inches. That's the volume, right? Let's see. And that's 100 foot, but we don't have to worry about that at this point. And then we've got 12 inches per cubic foot, and that's cubed, or actually 12 inches per foot cubed. So that takes care of your volume, right? The unit weight is 490 pounds per cubic foot. So now we've got all of that cancels out the pounds per foot. When you get done, you've got 13.61 pounds per foot for that beam times 100 feet, right? So it looks like we're looking at 1,361 pounds just for the beam, or bar I should say. So the stress, the tensile stress in that is 1,361 pounds, and the area is 4 square inches, so you've got 340 pounds per square inch, and that's just based on the beam, or on the bar, right? Let's see, suspended vertically, so that would be in tension, wouldn't it? And that's what it says, the tensile stress. Since the allowable tensile stress is 24,000 psi, and the induced stress due to the bar's own weight is 340 psi, the difference between the two represents the stress that can be induced by the force. Hence, the allowable load the bar can safely support at its lower end is calculated as follows: 24,000 psi minus 340 psi times 4 inches, 4 square inches. So that bar can withstand another 94,640 pounds. Is that correct? Looks to me like. Plus the weight of the bar, right? So that's just we've done everything but that one. Well, actually we did a force one at the very beginning, didn't we? With the rods. The only difference here is they had to get that broken down into pounds per foot instead of the volume. Well, I think I'm going to leave you with that. I think we'll do shear stress next class. And what I'd like for you to do I got two things for you to do. And you've got some time to do some of the problems right now, don't you? Before we even leave. I'd like for you to do the problems, and then I'd really like for you to go ahead and look over that next section between now and Wednesday. In fact, why don't you look over that section and the section on tensile and compressive strain and deformation. Holy cow, we could almost, we might, I don't know if we can get through the rest of the chapter, but then there's shear strain, relationship between stress and strain, Hooke's law, and then that's about it, I think. Yeah. So what I'd like to do today then is we'll just finish up those problems, and then like I said, we'll do shear stress, tensile and compressive strain and deformation, and maybe even shear strain for Wednesday. But go ahead and look over this. It's only like 5 pages. But if you're familiar with them, it might make it a little bit easier come Wednesday. Okay? Because right now your head's just kind of spinning, isn't it? Thinking, what am I getting into now? Okay, I understand that. So, problems to do between now and Wednesday. Of course, you'll see the solutions pop up there sometime soon. How about let's do problem number 2. This is on page 194. And like I said, you can stay here and do some of these problems and walk away feeling really good about that. 9.2, 9.3, 9.5. You could probably get these done before you walked out of here. 9.7. And that would get you through section 9.2 in the chapter. And then we'll deal with shear and such after Wednesday. Okay? So do those problems.
2, 3, 5, and 7.
Yeah.
And then 9.3
through 9.5. Yeah. That would be good.